Aloha class, here we go. 8-1, polar, intro, and derivative. So we just got done with parametrics. The cool thing is the calculus that we use with parametrics is somewhat similar to the calculus we use with polars. However, a lot of us, right, coming from honors pre-calculus, we have yet to be introduced to polars. So my job here in this first lesson is kind of really is to make sure we all have a good basis and a good understanding of polars. Okay, so here we go. This is what we call a polar coordinate axis, right? Kind of different from our traditional rectangular coordinates where we have a y-axis and an x-axis. Instead, what we have is we have a pole. Pole is kind of what the origin that we call in our rectangular coordinates. But our pole is actually our origin. And then we have what we call a polar axis. Now, we have these little circles here. And those are kind of like our r, if we want to kind of associate that with our radius. Okay? And so, for example, if I was to draw a line out here and say, what would the coordinates of that point be? I kind of gave you a cheat right here. But the way we do polar coordinates is we always put our radius first and then our angle second. So if you can imagine that angle right there is pi over 4, right? Looks like, let me get rid of some of that. Looks like 45 degrees. Okay? So if I look at that with my angle right there, that looks like pi over 4. Okay, and it is. It happens to be r comma theta. So that'd be pi over 4. Now, how do I get the 4 as my radius, right? Well, I get that by this being the pole. 1, 2, 3, 4. Booyah! Now, the question is when we're dealing with, and why do we even have something as like polar? Well, polar allows us to graph very elaborate functions, right? And we have very elaborate shapes all over this world. We have roses, we've got petals, we've got leaves, we've got craziness, right? So we have to be a way to graph all of these things. And rectangular coordinates just, you don't get the job done. Homie, you didn't get the job done. So we got buddy buds, right? And that's kind of what the essence of it is, okay? It allows us to do things that are more elaborate. Now, for a brief introduction here, what else could I call that point? Well, hopefully you're really thinking at home and you're like, well, hey, I could probably call that guy, what if I went this way instead? Well, what would my angle be? Well, my angle in that situation would be negative 7 pi over 4, right, class? Right, that would be going this way. That'd be negative 7 pi over 4, and it's still out 1, 2, 3, 4. How about it? So it'd still be 4 comma. Those would give me the same exact points. Now, if you're really doing an amazing job of thinking about things, you're like, well, hey, Mr. Tanaka, what about this? Could I possibly even call it some other things? And believe it or not, you could. For example, let's say that's my point, okay? And let's say that, let's go all the way to 5 pi over 4, right, class? That would be 5 pi over 4. So I actually could go 5 pi over 4. And if I think about my angle being 5 pi over 4, 1, 2, 3, 4, that would be 4 comma 5 pi over 4. But I want the same as that point right there. But guess what? This guy actually goes through. So if I actually put a negative 4 there, when I'm at 5 pi over 4, it says to go out in this direction. But since it's negative 1, 2, 3, 4, that, believe it or not, is the same exact point as that. Crazy, right? But it's actually true. So believe it or not, I could give it another answer for a negative, right, class? Instead of going 5 pi over 4, I could go negative 3 pi over 4. So there's actually 4 names. There's actually an infinite amount of names, right, class, that I could give that bad boy? Because I could just go, just keep on going 360, right? Keep on adding 360. But those are the 4 most common names that we give for that particular point. Okay, so that's kind of our introduction here to what polar coordinates are all about. Now, we definitely, well, I think I gave myself enough space there. Once again, I can't fix this pen. But I definitely want to relate rectangular with polar coordinates. Now, how the heck could I do that? Well, right triangle, that would be theta. That would be r. If I wanted to bring rectangular coordinates into this, I need an x and I need a y. How about it? Okay, so one way I could relate my polars with my rectangulars is how do I maybe create an equation, right? One equation we all could think about is x squared plus y squared equals r squared. So there we go. That's us relating our rectangular coordinates with our polar. What's another way I could relate the two? Well, the way I could relate the two is put r in terms of x's and y's, or maybe a theta. And the other way I could do this is I could write, well, tangent theta is equal to y over x, right? There's your polar, there's your rectangular, there's your rectangular, there's your polar. There we go. I associated the two. Now, is there any other way I could associate polar with rectangular? And believe it or not, there is. Because if I redraw, whoops, give me that pen. If I redraw that guy, right, and I go there, and that's my r, and that's y, and that's x, and that's theta. What if I brought up like a cosine or a sine? Let's go ahead. Let's write cosine's relationship, right? That would be polar, okay, is equal to, and that would be the adjacent over the hypotenuse. Well, that kind of, I just, okay, I could just multiply that r on the other side, or on both sides, and there we go. That's x in terms of your polar coordinates. And believe it or not, I could do the same exact thing with sine, right? That's opposite over the hypotenuse, and then if I just multiply, I get all the polars on one side and the rectangular on the other. So there we go, and we're going to use those moving forward. So make sure every equation I just wrote down right there, right? I got this big pen right now, so I've got to keep erasing. So I apologize for that. But make sure you have those four memorized: 1, 2, and the 2 from the previous page. Okay. All right. Let's keep rolling here. All right. We get to get into some really cool stuff, and we get to graph these bad boys. And I do not know how this is going to work out, but we're going to try our best, okay? Because this pen writes kind of big. How do I graph r equals cosine theta? Well, let's go ahead and make a r and a theta chart, right? And let's all start at 0 because, right, we'll start at 0 degrees. And if I put a 0 in there, cosine of 0 is 1. So I'm going to go here, since I have a big marker, I'm going to go by halves, all right? So we're going to call that 1. So I'm going to make my little point right there. Okay, now what's another point I can maybe pick? I'm going to pick pi over 3. Now, why am I going to pick pi over 3? Well, pi over 3 is 60 degrees, and I know at 60 degrees, my cosine is 1/2. All right, well, where would 60 degrees be? 60 degrees would be about right there, and then I'm going to go a half out, so it'd be about right there. Oh, snap, I'm already getting, I need a smaller marker. Pause it. All right, sorry, class. We're just going to have to use this big marker, okay? I could not figure this bad boy out. Okay, pi over 2 would be next in succession, and if I put a pi over 2 in there, I get a 0. So if I wanted to draw what this looked like, it kind of looked like that. It kind of looks very circular. After pi over 2, I could pick 2 pi over 3. Why would I want to choose that? Because that would be negative 1/2. Now, where is 2 pi over 3? 2 pi over 3 is 120 degrees, but it's negative, so I'm going out this way, right? And I'm going to make a point at a half, so I get about right there. What should I pick after that? I'm going to pick pi. If I plug pi, what do I get? Ooh, I get a negative 1. So pi goes out this way, right? And I should go out, but I got to go negative 1, which means I'm actually going backwards and gets me back to the original. So if you notice something, I get a circle, okay? And I can pick more values if you wanted to, or just trust me, it makes a beautiful circle. Now, what else do I notice about that? That's symmetric about the x-axis, and it has a diameter of 1. Okay, let's go ahead and graph the next one. Now, I might do it a little bit quicker because, unfortunately, my pen's not doing the best job. All right, so here we go. Once again, I should probably think of it as r comma theta. Oh, now my pen doesn't even work, but maybe that is a blessing in disguise. Maybe this dude would actually work out nicer now. We're going to go ahead and see. Okay, we have r. Oh, it still writes big. What the what? Okay, if I put a 0 in there and we're graphing this guy right now, 0 would give me a 2. So let's go ahead and go by lengths of, let's say that's 1 and that's 2. So I go ahead and make my value right there. Okay, and then once again, I should pick pi over 3. Why? Because I know cosine of pi over 3 is a half, so that'd be 1. Now pi over 3 would be, there we go, and I would go out 1, so it'd be about there. Okay, and believe it or not, I'm going to finish this. It's going to make a circle. If you look here, the diameter is 2. It's symmetric about the x-axis. Huh, how about it? Do you think you can draw the next one with no help from me? Let's go ahead and see if we could do that. Okay, well here, it looks like there's a tree there. Well, if I plug in a 0, I get 0, 3. So I'm going to go ahead and make that 3 this time. And then guess what? It's just going to be a circle with a diameter of what, class? Tree. I know it's not a circle, but it's supposed to be a circle. Okay, class, what happens if it ends up being a negative instead? Well, guess what? If I put in a 0, it's going to be 0, comma, right? If I do my little r and my little theta, and I start out with 0, I'm going to get -3 because cosine of 0 is 1. -3 times 1 is -3. So instead of going this way 3, I got to go backwards, right? So I'm going to go there. And so believe it or not, this is going to give me a circle with a diameter, again, of tree. Okay, but it's going to go out to the left. But guess what? Since all of these guys are cosine, they're all symmetric about the x-axis. How about it? Now, can you think of what maybe happens when we're dealing with signage? Okay, what happens when we're dealing with sine? Well, let's go ahead and do it. Let's graph this first one, the most basic one, r comma theta, right? Let's plug in a 0. I get 0 comma 0, right? And then I could plug in, this time I should probably plug in a pi over 6. Now, why a pi over 6? Because at pi over 6, right, that's 30 degrees, my sine is 1/2. So then I would get 1/2. Pi over 6 is out this way. So then I'm going to go 1/2 out there. So it's like my circle is starting, right? And then we go to pi over 2. Sine of pi over 2 is ichi. Okay, so if I go by halves, it's going to give me to 1. And then I'm going to come back down here. Okay, and you could pick the other values, right? I should pick 5 pi over 6, which would be 1/2 again. And then I could pick pi. And if I pick pi, it gets me back to 0, right? And I get my beautiful circle. But guess what? This one's symmetric about the y-axis. How about it? Cosine, symmetric about the x-axis. Sine, symmetric about the y-axis. And all of these are circles. Okay, what about that guy? Well, if I relate it to the one I did above, which was the cosine one, instead we're going to go by halves again, and it's going to be a circle, but it's going to have a diameter of right, of 2. Okay, what about this guy? Well, this time I'm going to go by ones, and it'd be a circle. And once again, you can pick the, oh, that's not bad of a circle. What's up? Okay, what happens if I put a little negative there? Well, it's going to be, once again, r comma theta. If I put 0, 0, so I still start there. However, I'm going to skip my pi over 6. I'm going to go to pi over 2. And if I plug pi over 2 in there, I put a 1 in there, I get -3 times 1, which is, oh, I'm sorry, -3 times, yes, 1, which is -3. So at pi over 2, I'm not going to go up, but I'm going to go down 3. And so I get this to be my circle. And once again, each one of these circles gets graphed in a range from 0 to pi. Very important to take notice of. Okay, so when it says take notice of some things, I'm really hoping you guys are writing some things down. Now, I'm thinking I'm probably going to need a good little pen for these next guys, so see you in a minute. Okay, here we go. Let's see if this works here, class. I made them big and large for you, all right? So let's see how we go. I hope it works. All right, what happens if we get a little crazy and we go a little 2 plus 2 cosine theta? Guess what? It's not going to be a circle anymore. Let's check out what this bad boy might be. Okay, and the way we get this guy started is let's look at r comma theta again. Okay, let's start at 0, right? If I put a 0 in there, I get cosine of 0, which is 1. I get 2 plus 2, which is 4. So I get 1, 2, 3, 4. Okay, so we're starting there. And once again, a good one to pick whenever you're dealing with cosine is pi over 3. Now, why that? Because it's 60 degrees. And at 60 degrees, my cosine is 1/2. So it'd be 1/2. That'd be 2 plus 1, which is 3. If I'm going too fast for you, please come in. That's 60 degrees. And it'd be about 1, 2, 3, right? Going back to that polars that we talked about on the first. And it's going to be nicely curved, kind of like that. Okay. Next, I should pick pi over 2. Why? Because that's an easy guy to pick. Pi over 2 would be 0. So it'd be 2 plus 0, which would be 2. So at pi over 2, I would be 1, 2. I'd be there. Okay. It's coming down now. Cool. What's the next guy I should pick? Well, 2 pi over 3. Now, why 2 pi over 3? 2 pi over 3 is 120 degrees. Now, 120 degrees means cosine is going to be 1/2. Negative 1/2. Negative 1/2. So if I put a negative 1/2 in here for this cosine of theta, I get it ichi. I get it uno. So I'm only going to come out 1. So it's coming back a little bit. Okay. Well, it's definitely not a circle. And then next, I'm going to go ahead and pick pi. If I plug a pi in here, and if I put a pi, I'm going to get a negative 1. I get 0. So that is what you call a polar 0 whenever an angle gets you back to the polar. Okay, now what happens after that? If you notice this time, from 0 to pi, it does not graph the entire figure, right? For those circles, from 0 to pi, it kind of drew the entire thing. And then if we went on those circles, if we went from pi to 2 pi, it would just retrace it. It's kind of cool. Check it out in your calculators. We're actually going to do that in a little bit. All right, let's keep on going. What comes after pi? Well, I should do these thirds here if I really want to know what's going on. So the next would be 4 pi over 3. Well, 4 pi over 3, why am I picking that again? That would be 60. That'd be 240. That'd be this guy down here. Now, why am I picking that? Because that's -1/2. So if I put a -1/2 in there, I'm going to get a 1. So since it's positive, I'm going to go out in that direction. I'm going to go out 1. Ooh, there's definitely some nice symmetry going on, right, class? After 4 pi over 3, I'm going to go to 3 pi over 2. That's 270 degrees. That's going to put a 0 there, and it's going to be 2. So once again, I'm going to go out here. It's positive, so there's my point. Okay. Ooh, and I kind of get what's going on. And you can cheat it a little bit, right? If I put a 2 pi in there, I'm going to skip the last pi over 3, the 5 pi over 3, and I'm going to put a 2 pi there, and I'm going to get a 4. Okay, so it comes all the way back to there. That'd be 2 pi, right? Because it's 0 or 2 pi, positive 4, and booyah. Sweet. Oh my gosh, if I turn my head, that looks like a heart. And believe it or not, a heart. What kind of doctor is a heart doctor? A cardiovascular, right? So believe it or not, we call this guy a cardioid. Okay, that's the name of this dude. Pretty cool shape, right? Pretty darn cool shape. Now we're going to keep moving. Now, believe it or not, the AP genuinely does not make you draw these graphs, but you should have a very good idea of what they are about. Ooh, well, this guy's a little bit different, right? If you look, and I wish I could go back. Look at your notes right now. If you look at that cardioid, that was definitely still symmetric about the x-axis, right? And if you notice, it wasn't quite a circle. It was kind of a circular shape, ellipsis shape, but actually a heart shape, right? And that's why we call it a cardioid. And if you notice, the constant, the 2 out in front, was the same as the coefficient of the cosine, the 2 and 2. Here, the constant is different from the coefficient. Will that make a difference in the graph? Let's find out. Now, if you really want to be challenged, really want to be good in this class, you're going to hit pause and see if you can do this on your own. We'll start at 0. Plug a 0 in there, I get a 1, I get a tree. So I'm going to start right there for this particular shape. Ooh, I probably should move it up a little bit. Maybe that guy we'll get rid of. We'll check it out. Hey, let's go. Okay, next one. Pi over tree, that's 60 degrees. Why do I pick that one? Because that's 60 degrees right there. And I know that if I plug that in there, I get 1/2. I'll get 1 plus 1, which is 2. So I got to go out 2 here. Okay. That kind of looks, actually, that's very similar to what we just did, right? Kind of circular. Next guy I should pick is pi over 2. Put that in there. I get a 0, so that's a 1. It means it comes back to there. Okay. Kind of cool. Look at this dude. What's going on with this guy? All right, let's go ahead and pick 2 pi over 3. Why do I pick that? That time, now I'm out here, right? That would be 2 pi over 3. Right, that'd be pi over 3. And if I plug a 2 pi, I get a -1/2. That gives me 0, so that would be a polar 0. So that's actually going to come, and it's going to come right back, and it's going to be 0, right? I'm going to make that point. And you know what? You could pick more points if you don't believe me, but that's exactly what it would look like, okay? I'm just giving you enough to get a good graph here. All right, so what should I pick next? Well, the next I would be is at pi, right? From 120 all the way to pi. If I plug a pi in there, oh, snap. I get a -1. 1 plus 2 times, that'd give me a -1. Well, that's pi out this way. But that'd be for the positive, so it goes there. So what is this thing doing? Let's see, it goes like that. How's it going to get to there? I could pick more points or just trust the way it's going. Okay, cool. All right, now I better pick 4 pi over 3. Okay, well, if I pick 4 pi over 3 for the next guy, 4 pi over 3 is this guy right here, right? Okay, it's kind of on line with that, right? But this would be 4 pi over 3. If I plug a 4 pi over 3 in there, I get a -1/2. If I put a negative, I get 0. That's a polar 0 again. So it's going to, let's see. It goes boom, 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 boom. I definitely am seeing what's going on. And you can cheat it once you kind of get a pattern. There's definitely a pattern going on here. I could go to 3 pi over 2 next. Right, 3 pi over 2 will give you a 0 for all of that stuff. So it gives you 1 plus 0, which is 1. So I'm going to come down here, right, because that's my 3 pi over 2. right? And then it's going to go to there, and guess what's going to happen for the rest? Booyah. Oh, sweet. That's kind of like a cardioid with the loop in it. And that dude's got a special name. What is that dude's special name? Limation. It's called a limation. Limation, right? I'm told it's like French for like snail or something like that. Maybe because it's going so long when you draw that one. If you notice these cardioids and limation, right? They're drawn from 0 to 2 pi, right? If I just go from 0 to pi, I just get half of it. 0 to 2 pi graphs the entire one, unlike the circles. How about it? Oh, look at this. Since these guys were different, that's why I had that interloop. How long is this? Ooh, that's a length of 1. Oh, snap, for reals? Okay, what's this length right here? That's a length of 2. Huh, interesting. And you want to pay attention to those things as you graph these, all right? There's going to be a lot of questions on the bottom here. Make sure you answer them. Let's keep rolling. These are kind of fun. They are so beautiful. Oh, okay, this is scenario number 3. Well, it's still cosine, so it's probably going to be symmetric about the x-axis. I don't think it's going to be a cardioid because those guys are different. It could be a limation, right? It could be a limation because they're different. But this time, this number is bigger than that number. I wonder if that makes a difference. Let's check it out. Let's see. R theta. Okay, let's start with 0 again. 0 would be 1, so that'd be tree. So once again, I start out there. It's kind of like it's been common for all of these guys. All right, next I should pick pi over 3. Why? Because that's 60 degrees, and I can handle 60 degrees, except this time, 60 degrees would be 1/2. 1 times a half is a half, so it's 2.5. So I got to go out 2.5. So I got, okay, very, very similar to what we've been doing. My next one would be pi over 2, which would give me a 0 here, but I'm going to go to 2 then. Huh, interesting. It's kind of almost more circular. And how about it? Sweet. You get to see my face up close. Okay, so I'm going to get 2, so it's there. Okay, and it actually comes down a little bit, it seems like, right? Let's see how we can do here with the pen. Okay, it comes down a little bit. Okay, let's see what, as we go on, 2 pi over tree. And why am I picking that one? Because that's 2 pi over tree, which would be a negative 1/2. Ooh, so if that's a negative 1/2, that would be 1.5. So then I'm coming down a little bit, right? Because that'd be 1.5 be somewhere about there. So now it's coming down. Okay, it's kind of getting, is it a limation or is it a cardioid? Let's take a look at it. Let's go ahead and pick pi as my next guy. If I pick pi as in my next guy, let's see what we get right here. Oh, okay. I get a negative 1 there. 2 plus a negative 1 is a 1. So, okay. So it goes, okay. It's not, well, a cardioid's going to get back to the polar, right? Limation, right, gets to the polar and kind of makes a loop. What's this guy do? I guess I got to keep on going. Let's go 4 pi over 3. Why pick that one? Because we know it's going to be a half. Okay, but it's going to be a negative 1/2. Well, if it's negative 1/2, oh, look at that. If it's going to be negative, oh, snap. Did I make a boo-boo there? No, because this is going to be 1.5, right? So I'm going to go 1.5. It's in between 1, 2. So, okay. There's symmetry happening there. Let's go ahead and pick 3 pi over 2, right? Gets me all the way back to this 3 pi over 2. And let's see where we end. It's going to be 0, so I'm going to go down 2. Okay, so it's going to go there, right? And sorry about the pen. And then you can just take a guess of the rest. 2 pi is going to get you back, and it's going to give me 3. So guess what? This dude does have a special name. I'm not even going to try to write it. You can actually call this is what we call a dimpled, like I got a dimple. It's a dimpled limation or a dimpled cardioid. And you can use either or. That's when it doesn't get back to the polar. It's not a circle. It's not quite a cardioid because a cardioid touches the polar. It's not quite a limation because a limation would get back to the polar and then loopity-loop. Okay, but it's kind of a combination of the both. It's got a little dimple. Okay, that's me. That's what they called it way back in the day. All right, let's keep rolling. All right, now here we go. I want you to really think. What the heck do you think this dude is going to look like, right? What is this guy going to look like? If it's very similar, right? This looks very cardioid-ish because that's a 2 and that's a 2, right? But this time it's sine. All right. You know what? I bet you what I'd love for you to do is hit pause. Don't even do an r and a theta. And you just know if it's cosine, it's symmetric about the x-axis. If it's sine, it's symmetric about the y-axis, right? What would this guy look like? And believe it or not, it is a cardioid because that 2, that constant matches up with that coefficient. And then when you're done, unpause this guy, and I'll go old school just one more time. Okay, and then we're going to kind of do this where I want you to be able to recognize these quickly so you can draw them quickly. And usually a good starting point, if you are a little confused, is just start at 0. And that can usually get you started. If I put a 0 in there for theta, that makes that whole thing 0 too. So I start right there. And believe it or not, you should have a good idea. If you knew it was a cardioid, let me do this one fast with you. Knowing that this is a cardioid, let's just go ahead and use our nice guys. Let's do pi over 2. Well, pi over 2 would be 1, so that'd be 1, 2, 3, 4. So, right, it goes up to there. Right, you could pick other values if you wanted to. I'm going to go all the way just to pi now. Okay, if I go all the way to pi, which is right there, that's going to be 0. So it's going to be 2. Okay, it's going to be a cardioid though. Remember, a cardioid is like a cardiovascular surgeon, so it better look like a heart, maybe upside down. Okay, let's keep on rolling. What's 3 pi over 2 give me? 3 pi over 2. So now since we kind of got the hang of it, that would be -1. So it would be 0. Remember, cardioids touch the polar. Are there a loop in that cardioid? No, there is not. So booyah, I am done. How about it? Not bad, right, class? All right, now for the next one, I want you to do the same thing. How quickly can you get that bad boy drawn? Okay, here's our scenario number 5. Okay, there we go. Okay, this number is bigger. The coefficient is bigger than the constant. So what does that mean? Limacon, right? So it's going to be a limacon. What's a limacon? It's a cardioid with a loopity-loop, right? And once again, let's see if we can draw this a little quicker. This one might be a little bit tougher, I think, because it touches the polar quite often, all right? But if I put a 0 in there, I get a ichi, get a 1, okay? Okay, let's go ahead and see if pi over 2. What's pi over 2 give me? That gives me a 3. 1, 2, 3. So it does actually go up, right? We don't have a loop yet. I don't have my loop, so there we go. We get that. If I go to pi, can I skip to pi? That gives me a 0. It gives me a ichi. Okay, so it gives me there. I probably should have went by halves, but that's okay. Now here's where it might get a little bit tricky, because if I go 3 pi over 2, 3 pi over 2, ooh, it gives me a -1. So 3 pi over 2 is right here. That'd be the positives. -1 means it would be right there. And actually, if you're really good and knew it was a limacon, you know that it has to come out here, right? That's the general shape of this guy, right? It's going to come out here, and then it's going to touch the polar, and then it's going to come spling, spling, right? Spling, 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 spling. And then you know when it gets back to 2 pi, it's going to go back to 1. There we go. There's my limacon, perpendicular to the y-axis. Why? Because it is signage. All right, here we go. See if you knew the last one. Easy peasy, jabon easy. What's the last one going to be? I bet you it's going to have a dimple. Now, why is it going to have a dimple? Well, it's going to have a dimple because that number is your constant, and it's bigger than that number, which is the coefficient. Remember, if they're the same, it is a cardioid. Okay, so this is probably going to be dimpled. Let's see how quickly we can draw this bad boy. Let's just use the nice guy. 0. 0, that is neat. Okay, pi over 2, that would be tree. Okay, and it's going to be a nice shape. You can pick more values if you don't trust me. Nicely curved. What's pi going to give me? Give me a 2 again. Okay, that. And then remember, there's no polar zeros on this one. It's not going to touch that polar. Don't touch it. Okay, we go to 3 pi over 2. What's 3 pi over 2? That'd be a negative. So that'd be a ichi. 1. So then it comes back to there, and then it's going to finish up by coming there. Dimpled cardioid, dimpled limacon. Okay, now I'm going to cut this video. We're going to have 2 of them for this section. Okay, this is your first one. Make sure you watch the second one. Aloha.